Hello everyone. In this video, I am going to discuss about vector spaces. This topic comes under in linear block codes and cyclic codes. Vector space is nothing but navigating multidimensional structures and linear combinations. This is called vector spaces. Recap. Before we start, recall our work with vectors in R power 2. We used arrows to represent direction and magnitude. Think of a force applied to an object. The hook, if you have a set of things, that is polynomials, functions, or matrices that you can add together and scale, could they be treated just like arrows in space? Discuss what properties must remain true for a mathematical system to keep it shape. Meet Rohan. In this problem statement, Rohan is a data scientist in Bangalore working on recommendation engines. He has millions of user preferences, that is, movies, ratings, and genres. The challenge is how does Rohan mathematically define the distance and similarity between users? He needs a framework to treat these complex data points as elements in a consistent, structured space. This is where vector spaces come in. Without these axioms, his algorithms would collapse. Define the code challenge, that is, closure property. If we add two things in our space, does the result stay inside the space? This is critical for system stability. Scaling consistency. If we stretch an element by a number, does it still behave predictable within the set? The zero element, every space needs an origin. Does our space have a unique zero vector that leaves elements unchanged? This is the technical depth for these vector spaces. Abstracting our view, by defining these on 10 rules, we can treat matrices and functions as vectors. This allows us to apply linear algebra to calculus and engineering. Here, matrix A plus matrix B equal to sum. In this A matrix, A, B, C, D. In B matrix, E, F, G, H. The sum is A plus E, B plus F, and C plus G, and D plus H. The prototype, consider the set of all 2 into 2 matrices. They follow addition and scaling rules, making them a valid vector space. Testing the prototype, the group check. In groups of 4, evaluate the set of all points in the first quadrant of R power 2, where x greater than 0 and y greater than 0. Does this set form a vector space? The hint is test the scalar multiplication axiom using a negative scalar like -1. Present your findings to the class. Here present are modern AI and future physics. The present is signal processing, representing radio waves as vectors in an infinite dimensional space to filter noise. In modern AI, in machine learning, word embedding, that is NLP, natural language processing, use vector space trope. So king minus man plus woman equal to queen. The future physics is quantum mechanics. The state of a subatomic particle is represented as a vector in a Hilbert space. Key takeaways. Formal definition. The non-empty set B over a field F satisfying addition and scalar multiplication axioms. In linear independence, the building blocks of the space vector that cannot be formed by others. basis and dimension, the minimum number of vectors need to span the entire space. The final assessment, a vector space that is contained within another larger vector space. This subspace, a real number of element of a field used for stretching vectors, that is scalar, a self-evident rule or requirement that must be satisfied span the set of all possible linear combinations of a set of vectors axiom. That is next final assessment. The vector space that is contained within another larger vector space is subspace. The real number of element of a field used for stretching vector is scalar. The set of all possible linear combinations of a set of vectors span a self-evident rule or requirement that must be satisfied axioms. Thank you for watching this video. Thank you so much.